Okay, everybody, let's continue with question 1D from 2024 paper 3. Okay, so in part C, right, we actually did a quick example of how Hacker's law can be actually used to deduce whether a structure is aromatic. So they say in figure 1.1, you have this parole is aromatic, okay, because it has 6 pi electrons, just like benzene ring. So those electrons actually can delocalize. Instead of a cyclohexagonal shape, now you have a cyclopentagonal shape. Okay, then they say nitrogen compound undergo the same type of hybridization as your carbon atom. So like sp, sp2, sp3, that kind of thing, right? By reference to orbital overlap and hybridization of nitrogen and carbon atoms suggests how sigma and pi bonds are formed in the parole molecule. Okay, so what do we need to answer, right? We need to reference to orbital overlap and the hybridization of nitrogen and carbon. Okay, suggest how sigma and pi bonds are formed. Okay, so we need to look at the hybridization, right? I think for all of these carbon, right, they are obviously sp2 hybridized. Okay, and we have to assume that nitrogen, right, is also going to be sp2 hybridized. Okay, because if you need at least one p orbital that's unhybridized so that it can delocalize. So I'm just going to draw the p orbital on each of them in the cyclic structure. So you can see that actually the electrons can delocalize in this structure itself. Okay, so carbon and nitrogen, all 5 of them is sp2 hybridized as I've labeled. Okay, and we need to describe how the sigma and pi bonds are formed. I think the sigma bonds, right, you just need to say that there's a head-on overlap between sp2 orbital. Okay, so let's write it down. Sigma bonds formed by head-on overlap between nitrogen and s orbital of hydrogen. Okay, so this will form like 6 sigma bonds. Okay, so after that, you want to form like the pi bonds. You actually form pi bonds are formed by the side-on overlap. Side-on overlap between carbon and nitrogen. They are p orbitals. Okay, so they will form a delocalized pi electron system. Okay, so that is it for Part D,